first column. Okay, so you have h1 of minus z minus h naught minus z. Oh, sorry. Is that right? Right. Okay, what delta z equal to? Remember how to find the component of a 2 by 2 matrix? This product minus that product, right? H naught of z, h1 of minus z, minus h1 of z, h naught minus z. Let me stop for question. Okay, let me summarize. So you need to look at stability, right? It's true that this solution is always like this, but it is useful solution or not. Then for arbitrary h, what I'm claiming here is that if you give me arbitrary h, I can always find a solution. But it might not be useful, it might not work. Right? A solution might have 0, it might not be stable, and causal unstable. And therefore you cannot build the system. Okay? So the next step you have to do is find useful solutions. So how do I define useful solution? How do I characterize useful solution? Okay, so is it stable, causal unstable, right? If my solution causal unstable, it means that there's no hole outside the unit circle. I think it causal unstable, right? Because even when you have FIR filter, the H not H1 is FIR. Okay, no hole. It's always causal unstable. No hole, right? If this is FIR, it is causal unstable. Do I guarantee F naught F1 to be causal unstable? No, I have hole here. Right? This can give me a hole outside the unit circle. So it's causal unstable 2, causal unstable F2. Which means that I have to design up to such that the determinant of Z has no hole outside unit circle, right? All the points inside. And it's hard to do because if I know the 0 of H and 0 of H1, this subtracting operation is very hard to work with. I cannot factor them out, so forth. So this is a very, very difficult problem to solve. The easier one to do is this means this one condition for this could be FIR, right? So the other easy one to solve is suppose that FIR is K of Z. How do I get FIR? Fk of Z. Tell me the condition such that Fk is FIR. Determinant to be it's a constant. Okay, I'm going to choose it to be equal to 2 determinant L. Sorry, this is cancelled. It's a shape, doesn't matter, right? This means that the determinant have to be a monomial. That's a delay. This delay factor can be anything. Okay, I'm going to choose it as L so that when I plug it in here, I have 1, just simple. If this is the case, then what is my filter? My filter is going to be F0 and F1. Very simple. It's going to be this. H1 of minus 3 minus H0 of minus 3. This in practice, right? So most of the useful wavelet filter bank is in this class. And that's the class we will concentrate the next few days on. Okay? The class where all the filters are FIR. And the class where the determinant of that matrix is a delay. Okay? Any questions? What can I say about this form? Is H1 is high pass. What is F0? It's high pass and low pass. Low pass, right? Because H1 is high pass. H1 of minus Z shift by pi become low pass. Okay? If H0 is low pass, what is H0 of minus Z? High pass. This minus sign only adds pi to the phase. It doesn't change what is high pass and low pass. It's a shift by pi phase. Okay, doesn't matter, right? It's still, so this is low pass, H0 of Z is low pass, H0 of minus Z is high pass, so this is high pass. That's what we want. We want the first branch to deal with low frequency. Second branch deal with high frequency. Okay? So we see that when we manipulate all of this, the two branches work together at the end. Basically the first branch, they're related, right? That's our solution. Okay? So we are basically having two conditions reduced to one condition now. Make the problem easier. Is that clear? Okay? So I want both to be FIR and FIR. Which implies that the determinant has to be a delay. Okay? So that's what I'm doing next. I'm going to write this equation again and set it equal to 2 theta minus L. And find H0, H1 to satisfy this condition. If I can do that, I'm done. Which means that F0 F1 is related like this. Okay? Is that clear? So 1 of minus Z minus 1 of Z F0 of minus Z 2 Z minus L. Okay? Here's the statement. Find H0 H1 as satisfy this equation. Is that clear? Now, I don't like this minus Z, okay? I want to change this to Z. So I want to substitute F into here. So this is H0, F0. Alright? And this is the minus sign. What do I get here? H0 of minus Z is minus F1. Plus H1 not that one. I'm going to go to F0 only, okay? H1 is F0 of minus Z. So F0 minus Z and then keep this one H0 1. Put this F here. In any case, what I'm doing here is substituting this into that. Okay? You can verify for yourself that's the case. What is that?
Minus.
Minus. So here is the way we do it. Instead of working with